Welcome to today's lesson on factoring. I am going to review a few problems that will help you to do the homework that you have assigned tonight. The first thing we're going to review is prime factorization. Prime factorization and finding the GCF are topics that can be found in section 8.1 of your algebra book. Remember that when I'm asked to find the prime factorization, they want me to take a number and break it down to only prime factors. So the first question I ask myself is, what two numbers could I multiply to get 90? The first two that pop into my head are 9 and 10. I then have to ask myself, is 9 a prime number? Remember that a prime number is a number that can only be divided by 1 in itself. So of course 9 is not, because 9 is this is the product of 3 and 3. 10 can be broken down to 2 times 5. These are all prime numbers. So when I go to write my prime factorization, the answer for this problem will be written with the numbers that are prime in ascending order, meaning I start with the smallest. So I get 2 times 3 times 3 times 5. This is how you might see the answer written in many textbooks. You will also sometimes see it written this way: 2 times 3 squared times 5. Both of these are perfectly acceptable answers. Sometimes I want to find the complete factorization of a term that includes both a number and a variable. You'll recall we call that a monomial. So in this case, I am asked to find the complete factorization. The way I like to do these problems is I still like to use a factor tree, just as I did above, for the number. So I'm going to take a look at 12 and see that that can be the product of 3 and 4. And 4, of course, is not prime, so I'm going to break that down to 2 times 2. So that means that my complete factorization of 12, a squared b cubed will be 2 times 2 times 3, and then I also have to list all of my variables. In this case, I have 2 a's and 3 b's. You might see it written this way. It's also acceptable to write it as 2 squared times 3, and again, don't forget all the variables. Sometimes I am asked to factor a number that's a negative number. And in that case, I always start out by first factoring out a negative 1. So if I have negative 66, that can be written as negative 1 times 66. 66 can be broken down into 3 times 22, and 22 is equal to 2 times 11. 3, 2, and 11 are all prime numbers. We don't call negative 1 prime because technically prime numbers are only numbers greater than 1 with factors of 1 in themselves. So in order to write this complete factorization, I'm going to write negative 1 times 2 times 3 times 11, and then I also have 2 x's and a y. And that would be my complete factorization. The other common problem that you will use involving factoring is to find the GCF. The GCF, you may recall, stands for the greatest common factor. So in this particular problem, I'm asked to find the greatest common factor shared by 18xy and 36y squared. In order to do this, I do each of my terms individually first. So over here, I'm going to start with 18xy. 18 can be written as 2 times 9, and 9 is 3 times 3. So over here, I'm going to write that 18xy equals 2 times 3 times 3 times x and y. 36y squared can be broken down so that 36 is equal to 3 times 12. 12 is 3 times 4, And again, 4 can be broken down to 2 times 2. So, for 36y squared, I have the factors 2, 2, 3, and 3. So 2 times 2 times 3 times 3, and I have 2 y's. At this point, to find the greatest common factor, I look to see which factors do they have in common and how many times. Both of these terms have 2 for a factor, but the 18 only has 1 2, so I can only select it once. They both have 3 here, and they both have a second 3, so I can select the 3 twice because both terms have 2 factors of 3. The last thing that they have in common is they each contain at least 1 y. So to find the greatest common factor, I now take all of the factors that I selected in one of the terms and multiply. 2 times 3 times 3 times y. And I'll find my greatest common factor is going to be 2 times 3 is 6 times 3 is 18y. So that means if I were looking to see what does 18xy have in common for factors with 36y squared, it would be 18y. I hope this will help you to do your homework.